So in this video, we are going to go over converting polar and rectangular equations. So we've been discussing the polar coordinate plane, and now we are going to talk about polar equations so that we can be ready to graph polar equations. So back and forth between them. So let's start with rectangular equations, and we're going to convert them to polar. So first off, let's be upfront. Everybody watching this video should know that x equals 5 is a vertical line, 1, 2, 3, 4, 5, and that is a vertical line. So what we're basically doing is we're going to convert this equation, x equals 5, so that we can graph the same vertical line on a polar coordinate plane. Alright? And so there's a couple things that we need to remember. If you don't, that's okay. But here we go. Things that you need to remember. You need to remember that x equals r cosine of theta. Y equals r sine of theta in regards to polar. X squared plus y squared equals r squared. And y over x equals tangent of theta. And I've written them in this specific way because we are going to be starting on the left side and substituting in, moving towards the right side. So here's the goal for converting a rectangular equation to a polar equation. Here's the goal. The goal is to have only r and theta in the equation. And we're actually going to want to make sure that r is kind of like y, like you would normally have y equals. We're going to have r equals. We're going to have r alone. So essentially it'll be a function or an equation solving for r in terms of theta. And that's where we're trying to get to. So here we go. X equals 5. We want to write this as a polar equation. So since I see and x, it is possible to substitute in what x equals in its polar context. And so I could say r cosine of theta equals 5. And so the first thing I did was I substituted, right? So that's allowed. Then the second thing I'm going to do is I'm going to get r alone. Oh my word, look at this, look at this. Alright, so as I get r alone, I'm just going to divide both sides by cosine. And then we are done. So I could say r equals 5 secant of theta. And so in the polar coordinate plane, like you could literally go to Desmos, change it to polar coordinate plane, and type 5 secant of theta, and you'd see a vertical line. And it's cool. So anyway, there we go. So substitution is a nice thing to use. We're going to do it a lot here in these problems, okay? And then the hard part is really just getting r alone. That would be the more difficult part. So in this case, look at what we got. We got y equals 2x minus 5. So what do we have here? Y equals 2x minus 5. What is that, right? We're not going to do this all the time, but I just want to point out y equals 2x minus 5. Go down 5. That's your y-intercept. Up 2 over 1. Right, up 2 over 1. We have a diagonal line, y equals 2x minus 5. There it is. And so what I'm saying is we are going to now convert this to polar. And if you were to put it into a calculator that graph polar equations, it would graph a line in the polar coordinate plane. That's what we're looking for here. So since we see a y, we can substitute something in for that. And since we see an x, we can substitute something in for that. So we'll sub in r sine of theta for y, and then 2r cosine of theta for x minus 5. And so I have r sine of theta equals 2r cosine of theta minus 5. Now from here, you've got to get r alone. So since you have two terms with an r, you should probably get them on the same side. So we'll say r sine of theta minus 2r cosine of theta equals negative 5. And we've done this before in class. So now we can't combine the two terms, but they both have an r, so we can factor, right? In this case, we can factor an r out. And what does that do for you, right? You have r sine of theta minus 2 cosine of theta. And look at the beauty of that. Now you went from having two r's in two terms. You now have just an r multiplied by this factor equals -5, and we can divide, and then r equals -5, right? And then it is sine of theta minus 2 cosine of theta. And then we're done. All right, and so r is alone. All right, let's try another. Interesting. We have 4x equals y squared, right? And so in order to use this equation, x squared plus y squared, you literally need an x squared and a y squared together. So we're not going to use that equation. So we're going to stick with what we used up above. And we're going to substitute in r cosine of theta for x, and then equals, right? And we're going to go r sine of theta, but it's squared. So now this is going to present some new problems for us. We have 4r cosine of theta equals r squared cosine, or excuse me, sine squared of theta. Now we're looking at this and we're saying, okay, if I were to move it all to one side and you factor an r out, you'd still have an r on the inside factor, if that's making sense. So I don't want to do that. So one thing that is allowed here is you can divide both sides. Wow, both sides is one word apparently. Both sides by r, okay? So you're going to divide both sides by r. So divide by r, divide by r. What does that do for us? Right? That gives us 4 cosine of theta left on this side and r sine of theta left on that side. Now I only have one r in the problem, and getting r alone should not be too difficult. And there we have it. That would be 4 cotangent of theta equals r, and that's going to be our equation. And if you're curious as to what this actually graphs, you could put it into things like Desmos. I think those work, but if they don't, that's actually a parabola on its side, and so there's like parabola on its side, which is kind of nice, kind of neat. And so then that parabola on its side would be the 4 cotangent of theta equals r in a polar coordinate plane. All right, so a couple strategies that we've got going on here, right? Substitution is going to be the big thing. Okay, so you're going to sub in any one of these 4 things, right, as we work through it. Factoring is going to be possible, could be helpful to get r alone, and dividing both sides by r is also okay to try and get r alone as you get the equation alone. Alright, so now here we go. See, this is the situation we like. This is easy, this is nice. Right, look at that. We have x squared plus y squared, so we're just going to immediately call this r squared equals 9, and we're going to get r alone through square rooting. That would be the best way. And so we can say r equals plus or minus 3. See, look at that. We love these ones. These are nice because you can just take care of it real easily, and everything's good to go. If it's not plus, though, you're out of luck. So, like, you can't use x squared plus y squared equals r squared in this scenario because it's x squared minus y squared, and there's no way to get x squared minus y squared out of this equation. So you're going to have to go to the other ones, and so you would literally have to do r cosine of theta squared minus r sine of theta squared equals 9. And then the goal is to get r alone. And so you have r squared cosine squared of theta minus r squared sine squared of theta equals 9. And then you can take r squared out. Factoring's good. Cosine squared of theta minus sine squared of theta equals 9. And I don't know if you know this, but you know, I want to save some ink and not have to write as much. And I don't know if you remember, but cosine squared, anytime I see something that's, you know, I can make smaller, I'd love to. especially if we're writing this all out. I don't know if you remember, but cosine squared minus sine squared is a thing. This is cosine of 2 theta. So I'm just going to write r squared times cosine of 2 theta. Look at that. Saving myself some ink. This is nice. I'm going to get r alone. R squared equals 9 over cosine of 2 theta. And then I'm going to square root. And so r equals plus or minus the square roots. Nope, square root of 9 is 3 over the square root of cosine of 2 theta. And let the math police come and get me. I'm going to leave the square root on the bottom. Gasp, I know. But who's going to stop us? No one. So we're going to keep going. Alright? Next, right? So hopefully that all makes sense. Remember, the goal is to just have r by itself with theta in the problem. The next one is, here we go, converting polar equations into rectangular equations. So now it's just the reverse, right? So the goal here, once again, is going to be to have only x and y in the final equation. Once again, those things that we said before are real, but we're going to start on this side. So we need to see r cosine of theta before we can substitute, and it would equal x. We need to see r sine of theta before we can substitute, and that would be y. If we see r squared, we can sub in x squared plus y squared. Hopefully that's nice. And if we see tangent of theta, we could put in y over x. Okay? So r equals 5 secant of theta. I feel like we already know what this is going to become, so that's good that we're starting here. So what would you do from this side of things, right? From this side of things, you're trying to get to either r cosine of theta, r sine of theta, r squared, or tangent of theta. So since we have a secant, it's probably best if we write this as r equals 5 over cosine. Like, we want the cosine to be present. And then from there, you want to get the r times the cosine, so it would make sense to cross multiply. So we would have 5 equals r cosine of theta. Now that I have the r cosine of theta, this is where we can substitute, right? So 5 equals x. And so we have only x's in the problem, which is good, because now we're rectangular, and we feel great. Okay? So let's try another one, same kind of idea. We have a fraction, r over 1 equals 1 over sine of theta minus cosine of theta. Cross multiplying probably is the best way to go to get rid of all the fractions. So I'd have r sine of theta minus r cosine of theta equals 1 times 1 is 1. And now notice, once again, here we are, r cosine of theta, r sine of theta are present. So we're going to say y minus x equals 1. This is beautiful. We normally would get y alone, so y equals x plus 1. Guys, this is a straight line with slope of 1 and y-intercept of 1. What a beautiful thing. Also, let's be honest, this is like the most complicated way to write a diagonal line. But anyway, math is awesome, so keep going. C here, oof. Alright, now we got strategies. We got to come up with strategies. We have r equals 2 minus cosine of theta, but when you think about it, there's no way that I can get r cosine of theta like as is. Do you know what I mean? Like, there's no way I'm going to be able to just solve an equation and get somehow this r times this cosine. That's not a thing. It's not happening. So we're going to have to come up with a better strategy for this, okay, to try and create this r cosine of theta. Alright, so what are we going to do? Well, new technique. In the past one, we were allowed to divide both sides by r, so it would make sense that I'm allowed to multiply both sides by r. And this is fine. This is good math. As long as you do one thing to one side and do it to the other side, you're okay. So I'm going to multiply this by r, and I'm going to multiply this by r. Now look at the beauty of this. What happens? I get r squared, that's a thing, we love that, equals, got to distribute, so I got to do 2r minus r cosine of theta. Okay, So we've got some things now to work with. What does r squared equal? I'll give you a second to write it down. R squared equals x squared plus y squared equals 2r, that's not anything, minus, and r cosine of theta is x. So after we multiply both sides by r, right, we're going to sub in, right, some things we know. Right, so x squared plus y squared goes in for r squared, and x goes in for r cosine of theta, right? But we still have this r in the problem, so man, gonna have to do some extra algebra work here. So we're gonna actually get this 2r alone. So we'd say x squared plus x plus y squared, right? Get everything on the left side equals just 2r. Now, I don't want to multiply both sides by r again. I get we could get an r squared on the right hand side, but multiplying by r means I got to put another r on the left side, and I don't want that. So guess what? Guess what? Let's square both sides. That's allowed, right? It's allowed to square both sides. Now, you're thinking, I get what you're thinking. You're thinking, you really want me to multiply this all out on the left? No, I don't. Just leave it. All right? Who's going to stop us? Nobody. All right? So there it is. And then I'm going to leave it as x squared plus x plus y squared equals 4r squared. And now, booyah, Grandma, we got an r squared. We're going to plug in x squared plus y squared. So we've got 4 x squared plus y squared and x squared plus x plus y squared squared. Now I can hear you. I can hear you already complaining that you're going to have to multiply this all out, combine like terms. Guess what? I'm going to let you stop right here. So thank you, thank you. I know you're thanking me for the kindness that I am exhibiting. Just leave it there. I mean, why do you want to multiply it out? What's it going to achieve? Nothing. I don't even know what this graphs. That looks insane. Okay, maybe I do know what it graphs, but that's kind of crazy. All right, so anyway, good chat. Last one is the last strategy. We have theta equals 45 degrees. That's weird, but we can actually do something which is kind of nice. We're going to take the tangent of both sides. My pen is freaking out. Alright, so take the tangent of both sides. Why though? Like, why would I do that? Well, because I don't have anything for theta, right? Like, there's no equation. I have tangent of theta equals x or y over x, but that's all I got. Like, I don't have anything else really for the theta there. And so when you're doing this, you want to take the tangent of both sides. So tangent of theta and tangent of 45 degrees. And what does that do for you? Well, it creates this opportunity for you to substitute in, oh, I don't know why I wrote y over y. You want y over x. It creates the opportunity for that where it wasn't there before. So when it's just like an angle, theta equals an angle, where it seems convenient to take the tangent of both sides, you should do that, because tangent of theta is y over x. And what's the tangent of 45? 1, right? And so you have this opportunity to write the equation pretty straightforward. Multiply by x on both sides, y. No. Come on, pen. You can do it. Dude, so many kids right now are like, yes, this is my life. The stylus doesn't work. I get it. I exhibit your pain. I know it. I feel it. Y equals x. Yes, finally, let's leave it. Let's leave it. Let's call it a win. Y equals x. There's no r, no theta. That is it. So those are the strategies for converting from polar to rectangular. All right, have a great day.